Assalamu alaikum, welcome back to the channel. Today we are going to discuss about dynamic and static array. So first of all, before diving into the concept of dynamic and static array, we must know about the stack and heap. And basically, stack and heap are the RAM section. Stack hold the memory address of any primitive data type variable declared, and heap hold the memory address of the variables which are being allocated using the new pointer. So the basic difference between them is that stack hold the memory address of any primitive data type variable for limited scope. For example, if I define any type of variable in this scope, it will just get allocated into the stack section because it has the primitive data type. And then when the scope ends, the memory address for this variable ends. On the other hand, if I just allocate the memory on the heap, memory on the heap is allocated using the new pointer. So like this, if I have just declare a pointer to an array of 5 element, I have just declared it, and then this memory will not get free when this scope ends. The main advantage of declaring the allocating the memory on the heap is that we can use it throughout the program as long as we want, and this memory will be freed explicitly by us. We use this statement delete, there is a delete operator. We use this and it frees the memory whatever has been allocated on the heap. So main one advantage of using the stack heap memory over stack is that we just declare it on the heap, and then whenever we free that memory, it will get freed. While in the stack, we have this memory allocation for a limited scope. When that scope ends, the memory of our variables end. So coming back to the our arrays part, so first of all I would like to show you what is static array. If I just write a statement like this statement is this is an array, a static array which has a size of 5 elements, and this has been allocated on the stack section. So what do you mean by this? Everything declared on this stack has a consecutive set of memory blocks. For example, these memory blocks are like 1, 0, 1, 2, 3, 4, like this. These are consecutive. This array of 5 element has been stored into a section of stack on the consecutive memory blocks. For example, one after and after. While on the other hand, if I just allocate a memory on the heap, for example, if I declare the memory on the heap like this, it holds the same elements as well. Well, this memory has been allocated on the heap, and the main difference between these two is that the memory for this array has been allocated randomly. For example, not just like this memory has been allocated into a consecutive set of blocks on the stack, while this memory has been allocated into the heap on a random addresses. For example, first one will be stored on 21, second one can be stored on 43, and 65, 88, and 99. Now the basic thing is, you might be thinking that the access of which of the array will have a faster access to the element. You might be thinking that this one will have a faster access. No, this one will not has faster access all the way through. It's like hashing. This array allocation on the heap is like hashing, while this is a type of linear uh, type of searching for this. For example, if I want to just assess the if I want to just add the value to the second index, and then I point add the value 10, then it will not just directly dump onto this memory block, and this will allocate the 10 value on this memory block. No, it will just go on the set of the stack on which that whole array has been allocated. So suppose in the stack section has start from 0, so it will first go to 0, then 1, and then 2. So this will go linearly. On the other hand, and this will not go linearly. For example, if I want to access the second element of the this array, then this will not go linearly because the address has been generated randomly. So for example, if I have the address 67 for the second element, so it will directly jump onto this 67 memory address, and then it will just allocate the number over that. As I've told you that we have to free anything we have declared, like on the heap. So just remember this point: anything you declare on the heap, you must get to delete that element. If you don't delete that, this will give you, sorry, this was array 2. Anything declared on the heap must be deleted explicitly. Otherwise, this will cause a memory leak issue. Memory leak issue means that the memory of 5 element has been allocated. Now, for example, if we have integer type hold 4 bytes, and then we have to multiply it by 5, then it will be equal to 20 bytes. So 20 bytes memory has been allocated and it has not been freed if we don't write this statement. So freeing this memory is very necessary for our long-term programs. If we don't free that memory, then our program can get slow. For example, if I keep on allocated these memories, at some time the overall function will have the memory which has to be freed, um, uh, and the program will actually get slow. The point is that stack frees the memory automatically. For example, when the scope ends, the memory allocated for this stack array will end because it has been allocated on this stack, while this memory will not get freed until this statement has been called. So this memory will free when we end the program. So when the execution of the program ends, this memory, if anything, any memory allocated on the heap and not freed, this cause the abnormal termination of the program. It will return you the exit code 9. And the normal, if the program terminates successfully without any error, then it will return the code 0. Like this main function return a value, so it return the a code which indicates that how was the program execution. So in case of memory leak issue, we get a return code of 9. So this was it for our video. I hope you understand the basic concept of stack and heap, and then we have just go through the static and dynamic array. So this was it. Thank you very much for